The largest star in the Milky Way galaxy, our galaxy that is slowly dying, and astronomers are watching. Three-dimensional models of astronomical objects can be ridiculously complex. They can range from black holes that light does not even escape to the literal size of the universe and everything between. But not every object has received the attention needed to develop a complete model of it, but we can officially add another high complex model to our list. Astronomers at the University of Arizona developed a model of VY Canis Majoris, a red hypergiant that's quite possibly the largest star in the Milky Way, and they're going to use that model to predict how it will die. How red hypergiants die has been a matter of some debate recently. Initially, astronomers thought they simply exploded into a supernova, as so many others do, as stars do. However, more recent data showed a significant lack of supernova compared to the numbers that would be expected if red hypergiants themselves were to explode that way. The going theory now is that they are more likely to collapse into a black hole, which is much harder to observe directly than initially suggested supernova. It remains unclear what precisely the characteristics of the stars that would evolve into black holes are, and to find out, it would be beneficial to have a model. Enter the team from University of Arizona, UA. They picked up VY Canis Majoris as an excellent stand-in for the type of red hypergiants they were interested in learning more about, and the star itself is massive, ranging from 10 AU to 15 AU astronomical units in size. One astronomical unit is the distance between the Sun and our Earth, which is approximately 93 million miles. And this is only 3,009 light years away from our Earth as it is. It makes VY Canis Majoris, which resides in the southern constellation Canis Major, fascinating to observers. Its sheer size and proximity to our solar system make it an excellent observational candidate. With good observational data, astronomers can see the breathtaking complexity of what the star's surface actually looks like. One of the fundamental processes in the star's death is mass loss. Typically, this happens when gas and dust are blown evenly out of the star's photosphere. However, the VY Canis Majoris, on VY Canis Majoris, there are massive features that are similar to Earth's coronal arcs, but 1 billion times more massive. The UA researchers used time on ALMA to collect radio signals of the material that's blasted into space as parts of these eruptions. That material, including sulfur dioxide, silicon dioxide, and sodium chloride, would allow them to detect the speed at which it moves, rather than just the static presence of other ejecta such as dust. To do so, they had to align all 48 dishes of ALMA and collect over 1 terabyte of data to get the correct information. Processing all of that collected data can be pretty challenging, and they're still working on some of it. Still, they had enough so far to present their findings to the American Astronomical Society in mid-June. When they have even more data, they'll be able to describe an even better model of what one of the largest stars in the galaxy looks like. And someday, far in the future, that model of what will happen to a red hypergiant might just get a chance to be tested when VY Canis Majoris finally officially dies. This is from Universe Today, Andy Thomas Wick, and it's on Science Alert. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.